I want to thank everybody for coming this evening. We have a special presentation by Jeff W4DD. I reached out to Jeff about a month or a month and a half ago. I forget, but I read his spotlight in the August QST issue this year, and it was very fascinating on RFI. So I reached out to Jeff and I asked him to give us a presentation in here, and he graciously accepted. So we have just a few little ground rules. Everybody should mute. If you have a question, Jeff said that he can field it as long as it's a short question during his presentation. If it is a long question or something that may be lengthy, he asks that you wait until his presentation is over, then you can go ahead and ask the question. Now, I would recommend if you do have a question, instead of just jumping in there, at the bottom of the screen there's reactions, and you can actually raise your hand, and then Jeff could call on you, or if you wanted to, I guess you can just jump in. Jeff said he'll take it either way. So if you know how to raise your hand, then we can get some questions answered. Jeff did indicate it takes about an hour or so through this presentation, depending on how many questions he gets. So anyway, I'd like to turn it over to Jeff and welcome him to the East Coast Reflector Zoom room and all of its users in here. Okay, Jeff, over to you.
Okay, Tom, can you hear me okay? Good.
Yep.
Thanks for asking me to join. As Tom mentioned, my call W4DD. I live north of Atlanta, about 40 miles or so. I moved here 20 some years ago. Prior to that, I lived in Michigan. I had a WB88 call, and lived in Virginia for about 15 years or so. My background includes some time in telephone operations many years ago, where I worked on electronic switching machines, and spent about 15 years in Virginia working on air defense communications, and then about 20 years working cellular in Virginia. Prior to that, I did a little work at University of Michigan, obtained my double-E degree, and then decided I wanted to try something different, and worked on an MBA. So that's a little bit about me, and hopefully I'll learn something about you folks during the presentation. I have a presentation, usually runs about an hour, but Tom warned me this group has lots of questions, so it may run more like an hour and a half. So let me do a share screen and pop this up. Okay, you should see that. Let me come up here and do more and share sound, because there's some sound in this presentation. And let me expand this. So you should see a map on the screen. Is that correct?
Yep.
Okay, good. Thanks. Just give me a little feedback every so often to make sure that you're getting my audio okay, and then the video's okay. So I'll be talking about mostly about receive RFI, a little bit about transmit, but mostly about receive RFI. I got interested in this when I moved to Georgia about 20 some years ago, because I seem to have a lot of it, and I'm in a kind of a rural area, but it was pretty significant, and I had a hard time keeping it under control. So that's kind of my story, is my efforts to try and control the noise and keep it as low as possible. I like contesting. I like to be able to rag chew without hearing the buzz of power lines, or the odd sounds you get as birdies sweep across the spectrum. So tonight we'll talk about what is RFI. Do you have RFI? Some tools for detecting RFI and the location, simple tools, and then some much better tools. talk about some examples, a little bit about clearing distance guidelines. So how far out do you need to consider when you're looking for RFI? And then some results I've had in my area here and with people I've assisted. So RFI, acronym for radio frequency interference, a very broad term, and it's used to describe an undesired signal that interferes with reception. RFI on the receive side raises the base noise floor. The higher the noise floor, the fewer the signals we can hear. When the noise floor is low, even weak signals are very readable, and they sound much better, more like a stereo transmission than a simple sideband transmission. Many types of devices generate noise. Power lines and switching mode power supplies are the two most important and the most common. It's not unusual to have multiple devices creating RFI in your home or near your home. So power line noise is energy generated by high voltage arcing, very wide band, kind of like the old spark gap transmitters were 100 years ago, usually caused by unintended arcing between two metal conductors on a power pole. Like I said, it's basically a spark gap transmitter, and the effectiveness is dependent on the size of the arc and the antenna, which is basically the power line connected to it. And it can range from a very minimal annoyance on receive to well over S9, and I've seen S9 plus 20 or 30 noise sources. Many hardware causes, but the three most common for power line issues are defective insulators, defective lightning arresters, and metal-to-metal arcing on the pole. One interesting thing about PLN, it's usually a very wide band noise, so it affects everything from 160 and actually below that up through VHF. So that's one of the characteristics I look for when I talk to people about RFI and the issues they're experiencing. A different kind of RFI generated by switching mode power supplies, very common devices for powering cell phones, laptops, light bulbs, pretty much you name it. They are the by far the most common kind of power supply today. They're more efficient and less expensive to produce than the traditional linear supplies that are kind of heavy devices, typically like Astron power supplies or the wall warts we used to plug into the wall were pretty heavy. The new ones, the new styles are very lightweight units with very small transformers in them because the transformers operate much higher than 60 hertz, usually in the 20 kilohertz to 100 kilohertz range. If they're not well designed, and a good number of them are not, noise generated by the SMPSs generates a wideband noise, but it's more prevalent in the lower bands, 160, 80, and 40, although you'll see it extend higher than that in some cases. So why do we care about the noise floor? Well, a picture's worth 1,000 words, like they say. So I took two snapshots. The first one is the pan adapter of my radio on 40 meters. I had an S7 noise floor, and I looked across the spectrum that I could see at the time, and I found 11 workable stations, just doing a little scan through that. The noise went away a few minutes later, and it dropped to an S5, which is more typical noise floor for 40 meters. I could count 17 workable stations, so 50% increase in stations I could hear. And of course, you can not only hear them, but they also sound much better audio-wise, much clearer without distortion. So we should care about the noise floor as hams. It really aids us in being able to work stations. And also, if you just want to rag chew, it's much nicer to rag chew with somebody when they're sounding like a stereo FM transmission than it is if they're being distorted by noise. So do you have RFI? You power up your HF radio, pick the band and antenna of choice, whatever you operate most, find an unused frequency, set the mode to AM because it's much easier to hear the characteristics of RFI in AM mode. Set the filter to 6 kilohertz if it's not automatically selected that way already. And you hear something other than a low-level white noise, like a buzzing noise. What you should hear is a nice, pleasant hissing noise kind of like maybe the sea breeze at the ocean. But if you hear something that has any characteristics that do not sound random, like a buzz or any kind of man-made noise, then it's a good chance you have some RFI there. And it could vary from, only a couple of dB to 20, 30 dB of added noise. So let's listen to an example of noise, and you should see a old Kenwood transceiver, and I had a power line problem out in front of my house some years ago, and I recorded it. So here we go. So that certainly does not sound like the nice gentle hiss of white noise. So that was a real obvious one. You can't always tell if it's power line noise or something else, but that one had enough variation in it that it was pretty easy to tell it was a power line issue. Oops. So one of the first things I ask people when I work with them on power line issues is what bands are affected, because it can give you a really good idea. Is this a wideband problem, like extending up into VHF, or is it just stuck down at the low bands, 80 and 40? So I usually ask for information like, okay, on each band, take an S meter reading in AM mode and write down what your antenna is and what height it is. Some people will have Yagis at 50 feet or so, and that's important to know. But this gives us an idea as, does this noise extend into VHF? And the reason we want to know that is if it does, it's going to be a whole lot easier to find. If it's strictly a low band noise, then the tools we need to use are a little different than the tools we would use if we can track it at higher frequencies. And step B, if you have a directional antenna, that helps a great deal. What I usually do at home, here at my home station, if I have a noise problem, I step through the compass, take 12 readings, 30 degrees apart, and I write down the S meter reading or the dBm meter reading. And that will give me a real good idea of the directions I need to focus when I go out and look for it. There's no sense in looking to the northwest quadrant when I know it's in the northeast quadrant. And if you can kind of figure out what quadrant it is in, it really limits the amount of time and energy you have to expend finding it. Usually when you do this test, if you have a rotatable antenna, you want to pick the band where you have the best pattern on your directional antenna. So if you have a tri-band antenna and your, say, 10 meter configuration on that antenna is 5 elements, and on 20 meter configuration is only 3 elements, you probably want to use 10 meters because the pattern will be narrower and you'll be able to get a better focus on where the problem is. If you have only a 2-element Yagi, it's going to be not so refined of a focus. But I found with a 5-element Yagi on 10 meters, I can usually narrow it down to easily plus or minus 5 degrees of where I should be looking. So some simple tools, really simple tools for finding noise. First thing you want to do if you have noise, you want to make sure it's not coming from inside your own house. You want to rest assured it's outside problem, because you can spend a lot of time tracing noise and then come to find out, no, it's really a laptop power supply or something like that inside your house. So easiest way to do that is you turn off all the circuit breakers, powering your radio off, either one breaker or a battery, and see if the noise goes away. And if it goes away, yeah, it's inside your house. You need to look there. If it doesn't go away, then think about other things like, do you have any uninterruptible power supplies, UPSs that power computers or anything like that? UPSs can be very noisy, RF noisy. So you want to make sure those things are shut down when you're doing a test. Also, if you have fiber at your house, some of the fiber systems have battery backup, and some of those systems have UPSs installed in them, and they can generate noise too. So kind of keep those things in mind if you do the circuit breaker test. and make sure they're all powered off. Second most useful simple tool is a AM radio. You can walk around the house and it'll kind of give you an idea of what may be making noise. You won't always get a real clear source. It's a little hard to measure magnitude, and we'll talk about magnitude in a slide or two. But as you approach it, it'll get loud, but loud is a very relative thing, and things can sound loud sometimes, but they may not actually be all that strong RF-wise. So keep that in mind when you're trying to hunt noise. It's not how bad it sounds necessarily, it's how strong RF-wise it is. And the last tool, AM car radio, use that all the time. I will drive down a road and I can kind of tell based on my experience with my car radio in my truck is if it blinks the radio in AM mode, I know it's starting to be a significant noise source and I need to look at it further. Again, it doesn't provide a very good indication of magnitude. It just says, yeah, there's a problem in this area, but you really can't gauge the magnitude of the problem. One thing to consider too when you're hunting noise issues is the noise could be a very small source, like inside your QTH, or something big farther away. And we'll talk about those in more detail. Tom, if I miss any questions that pop up, just alert me.
Okay.
So much better tools. These are the tools I like to use because it really lets me track down the noise much more quickly. My most used tool is a simple 137 megahertz Yagi, my HT, and a 45 dB attenuator. And I have a scale column on here. You can detect noise both inside your house, if it's a wideband noise, or you can go outside and you can easily detect noise blocks, or I've even had or used it to find a pole that was a quarter mile away. That was a pretty bad pole. It had a bad lightning arrestor on it, but I could easily hear it and said, yeah, it's in this direction. It's down this road, and that's where we need to be looking. It provides both magnitude and direction because with the attenuator, you can flip in attenuation on the pad. And my attenuator has 4 levels, it has a 3, 6, 12, and a 24 for a total of 24 or 45 dB. The highest being 24, and then I can flip in more attenuation if needed. And what I do is I attenuate until the noise just goes away, and then I just bring it back. And that makes the noise hunting a very binary condition, where if I swing the Yagi in 330 degrees of the circle, I hear no noise. But when I swing past the direction it is in, the noise is very apparent. So you attenuate till you get rid of the noise except in one direction. That works extremely well. If you don't have an attenuator, it gets really hard to determine is the noise really in this direction or not. So I always encourage people, if you're going to build the Yagi, build the attenuator too, because it's a really important part of the set. The second thing I use quite a bit is an ultrasonic dish. You can ID the part on a pole, on a power pole. That's an audio device, but many times arcing produces audio components also. So you can identify what part it is and report that to your power company. So I use that quite a bit. And the third thing I use pretty extensively is something called RFI mapper. That's more useful for kind of wide area noise where you have to get out away from your QTH and maybe look out half mile or farther, maybe a mile. And it's most useful for hams that have Yagis on towers that are 50 or 100 feet tall. And that again provides both location and magnitude. And we'll dive into this a little deeper in some other slides. So I use these tools a lot. Probably everything I work on, with the exception of like a neighbor's or inside my house, I'll use all 3 of these tools. So first, the VHF Yagi, really a great tool. I have an old HT, a Yaesu VX5R, which maybe is 20 years old, and a 137 megahertz Yagi. I'd say it's essential for finding local noise one at a time, or if you're going to help the power company, you really need something like this so you can point to a pole and say, yes, this is the pole, and you can be very confident of it. 3-element 137 megahertz Yagi can be built on a broomstick. I built this one in the picture here probably 15 or 20 years ago. It was supposed to be a prototype, and I had the full intent to rebuild it to make it look prettier, but it just works so good that I've left it that way all the time. And all it is a broomstick and some 10-gauge wire that passed through the broomstick, and a little hairpin match for the driven element out to a piece of coax. That's all it is. And the front to back ratio is fantastic. And on the right-hand side, you see my attenuator, and that's actually a rebuild from a cable TV attenuator that wasn't working. The switches were bad, so I tore it apart, mounted some new slide switches in it, 12 resistors, couple connectors, and that's all there is to it. One question I get pretty much every presentation: why use 137 megahertz? Why not use 2 meters or 440? And what I find is AM mode works best for finding noise. Some HTs only do AM in the aircraft band. So on my initial HT many years ago, it only did AM in the aircraft band at 137. So I had to go to the aircraft band. Second really important thing is HTs will not transmit in the aircraft band. So the 45 dB attenuator you build will not get spoked if you accidentally depress the PTT button. And I've always been concerned about that, as one accidental depression of the PTT with a 1 watt or a 3 watt HT is going to smoke the little resistors in that attenuator box, and you're not going to look very competent to the power line folks as smoke comes out of your attenuator. So I always had that concern that this could be really bad. And of course, once the attenuator's damaged, you use your ability to attenuate and narrow down to the pole. So it didn't take me long to think through that one, go, no, I don't want to go there. I want to make sure the HT cannot transmit. The reason I like 2 meters, or in this case 137, is it provides good range and good pole resolution. I've detected poles as far as a 1/4 mile away, which is pretty long ways when it was a noisy one with a bad lightning arrestor. And I can also get up near poles, and by flipping in attenuation, I can knock the levels down enough where it's still a useful instrument. So I like the combination of those two. Some people like to use a UHF 440 for it, but I've tried that and it didn't provide the range I was looking for. I'd like to have one tool that kind of covers it all. And then 136 950 is usually a pretty quiet frequency. I usually hang around there at the top of the band. So a few hints for using the HT, Yagi, and attenuator. I'd say it's a must-have if you're going to work with the power company. It confirms what pole they should be working on. And a word of warning, I learned this thing, and I'll mention a lot of rabbit holes I've stepped in over the years as I've worked on stuff like this, basically mistakes I've made that I said, well, I'm never going to make that mistake again. Sometimes I do, but we'll talk about that more in a minute or so. The noise loudness is not always indicative of the RF level. Go by the RF level. That's what you're interested in. It may sound like a really nasty noise, but you may find it's only a 3 dB noise, and that's just not significant unless it's sitting next to your house. Attenuator, I find it's a necessity. People that build the Yagi and don't build the attenuator usually are not as successful as the folks that build both and use both. And the attenuator is really simple. It's a metal box, 4 slide switches, and 12 resistors. And I have plans for that if you want to build it. It's really a nice little project. Takes you, a night or two, but it's well worth doing. The hardest part of that is finding a small box. What I do is I rate my noises with that Yagi and attenuator. And that helps me decide, is this something I need to be concerned about or not? So if it's something like in the 0 to 12 dB range, and by 12 dB, I mean, it took me 12 dB to get rid of it on the handy talkie. I add attenuation until the noise goes away, then I back off a little bit. So if it's a 12 dB noise, and it's a 1/4 mile away or a 1/2 mile away, I'm probably not too concerned about it. You get up into 13 to 24, I call that a medium. 25 to 40, dB to get rid of the noise. I call that big. And if it's over 40 dB of attenuation, that's really a monster kind of a signal, and you need to be concerned about those even out to a half mile or a mile away. Something I've learned, poles with lots of high voltage lines on them may seem to cause a noise, but an adjacent pole with just one high voltage wire on it could be the culprit. And if you think about that, that makes sense. If you have a lot of antenna wire on an antenna, is going to generally broadcast a stronger signal than a antenna wire with just a little bit of wire. So what I do is when I am trying to decide which pole is causing a particular noise problem, I always stand midway between the two poles and do an A/B comparison, add in the attenuation until it goes away in one direction, flip back and forth with the Yagi, and that will always tell the story. I have a little example of falling into rabbit holes. I was out working with my power line guy one day, and we'd walk through a neighborhood tracing this noise, and I kept telling my now friend Vic, it's on the next road over. We'd go over there, I'd take a reading, and I said, oh, it's still over farther. And then finally, it was across a creek, and I said, well, it looks like there's a road over there, but we can't get to the road. And he looked at his map that he can pull up on his computer and says, there's a power line on the other road. We have to get to it in a roundabout way. So we went over there. I jumped out of my truck, took the Yagi, did an A/B comparison, and says, hey, it's that pole. And he walked over and he scanned the pole with his ultrasonic dish. And usually when working together, I'll work the Yagi RF side, since I know that best, and he'll work the dish with the commercial ultrasonic dish he has. And as soon as he scanned the pole, I knew that I was in trouble, because he scanned the pole and he smiled and he started walking down the driveway, and I did not notice there was a line going down a driveway. I thought the line just continued on down the road. Well, he gets halfway down the driveway and there's a pole in the driveway next to the garage. He scans it and says, no, Jeff, it's this pole here next to the garage. So that was a good example of pay attention to where those lines go, do an A/B comparison on all sides of the pole that have high voltage lines, and it should always lead you back to the pole causing the noise. And I've learned this lesson enough times. I swear I'll never have to relearn it, but I've said that before. So another one of my tools, I built a ultrasonic dish some years ago, and I use that when I'm out by myself and my power line guy is not out there. It's a little hard to carry both the dish and the Yagi and the HT and all that, so I usually use one at a time. But this is coming really handy because I can identify parts on a pole, and I've added a few things to mine. A 1X scope, hand grip, and then a box for the electronics, so I can work on electronics and change it out and make changes to it. And the scope is coming really handy. The commercial unit has a mechanical sight, which works pretty good, but the red dot, green dot scope works really good. And a number of folks have added that to their dish. And I can usually pinpoint down to within maybe 3 or 4 inches of what part is causing the problem. And in high voltage work, most parts are not 3 or 4 inches away from one another. There's more separation because you're working at 7 or 14,000 volts. So I can usually pinpoint the issue on the pole, and I'll report that to my power line guys. And sometimes he goes out and confirms it, and sometimes he just writes a service order to replace what I've asked him to replace. So usually when you're out in the field with the power company, you're going to handle the RF aspect because you're the RF expert as a ham. And then the power company is going to handle the ultrasonic, and most power companies will have an ultrasonic dish. But there's times when you may want to do your own troubleshooting and have a dish too. As I mentioned, I added a few extra things to mine to make it a little more accurate, but those things are just frosting on the cake. So what does power pole hardware look like? I'd say probably about 80% of the noise I run across is power line generated, and it can be quite severe at times. And maybe 20% is other sources like switching mode power supplies or things inside the house, everything from washing machines to who knows what. So here's a picture of a simple power pole. It's a single phase power pole, so there's only one high voltage line on this. And you can see the high voltage line at the top. There's a pole top insulator. There's a lightning arrestor, and then there's also what they call a cutout, which to us is a switch, and it's a little white skinny thing shown on that picture. There's a hook there. They can grab that fuse and pull the fuse out of the holder and energize or unenergize the drop circuit that goes to the house. They can do that very easily. They don't like to unless they have to, but they will when they go to replace things. There's typically some kind of a bell insulator that feeds the drop line. There's usually one of those each end of the circuit. You'll see the neutral wire below the pole. And I've highlighted the things most often causing problems. The bell insulators are probably the most common, followed by the pole top insulators. But when you run across a lightning arrestor, it'll be typically very nasty. And this particular lightning arrestor is one of the newer style, which is a rubber coated type. And they're a little harder to find with the ultrasonic. The old ones were porcelain, and they were really easy to locate because they vibrated when arcing took place, but the new rubber coated ones are a little tougher. Just a word of warning, don't ever touch power pole hardware. Your mission is to observe and diagnose without touching anything dangerous. That's the power company's business, and that's the way I look at it too, is I should be able to find the cause of the problem without touching any of their hardware. Do I have any questions so far? Okay. So when you find a problem, who do you contact? Well, I usually start with opening a trouble ticket with the power company. Usually you end up with the dispatch crew, not the dispatch crew, but the customer support crew. And sometimes you get someone who knows what you're talking about, and most of the time you'll get someone who has no idea what you're talking about. And you just have to explain what the issue is and ask if they forward it over to the engineering department. It's usually kind of the group that looks at it initially. There's usually an expert in the engineering department that handles these kinds of problems. In small companies, it may get forwarded directly to the operations group, but most of the time it'll go to engineering. You don't want to give them 20 things to chase. As an RF expert, you want to kind of narrow down what it is you want to be looked at. And I usually pick the worst 3 or 4 poles at a time. So that's where the attenuator comes in handy. You can get a really good idea of what the likely causes are. What I like to do is I like to work an area and identify the issues, the big issues in that area. When I first started doing this many years ago, I'd find a problem, report it, the line crew would come out, or usually the engineer would come out first and say, yeah, it's on this pole, it's this insulator. They'd work that pole and the noise would get a little better for a while. There'd be another pole, maybe on the next block over. So when I first started, I had seemingly lots of problems. And what I found was it's just better to kind of get the big picture, identify the poles in the area, especially if they're adjacent to one another or very close, and the line crew just clears them all within a half a day. They're next to one another. The setup time is very minimal. They can, step down them, and they're really good at doing their job. It's really amazing how good they are. But just getting to the pole from their dispatch center takes time. So if you get them out there, it's better to clearly identify the poles that may be an issue and then kind of rate the ones you think are the worst ones. Usually the power company engineer will have an ultrasonic detector, and the one they use most often is the radar engineer's RE250 or 251, and that works pretty good. And then the engineer will schedule a line crew to work the problem. Always offer to be on site, and that's where the HT attenuator and Yagi come in handy, because you can be right there. And I usually leave my audio on speaker, not on the headphones, but on the speaker. And so I can point to the pole, and that usually is a really good convincer. As you swing the Yagi back and forth, it'll go from no noise to blaring noise when you point to a pole. And then they know that, hey, something's not right with that pole. This guy is not making this stuff up. I think over time you'll find you have pretty good credibility. You build credibility with your power company, and when you report things, they're quite agreeable to working on them because matter of fact, we'll talk about one that I reported. It was actually potentially a safety issue. So the third tool I've been using for about 7 years or so is something I call RFI Mapper. Here's an example of what it looks like with a couple of issues I found, and we'll talk about how Mapper works. So why did I need a new tool? Well, I had about 10 years of PLN, power line noise, and sometimes they were big, sometimes small, sometimes they were always on, sometimes intermittent. I spent a lot of days and it can get pretty cold in Georgia in the wintertime. I mean, you can get a 20-mile-an-hour wind and a 20-degree temperature, and I don't like going out walking the neighborhood when it's that cold, especially if you have to walk a long distance. I could kind of get a general sense of direction with my HF beam, but that doesn't find the pole. That just tells you where to look. And it got very time consuming and tedious walking roads with the Yagi and evaluating, comparing, how strong is it? Finding one problem, they come out and fix it, and the noise was still significant. Once in a while, the VHF noise would not necessarily correspond to the HF noise. That was always an issue. So anyway, after a lot of years of work, I just could never get the noise under control for any length of time, just too many sources over too large an area. And the final straw was an S9 plus 10 noise I had to the southeast. And I had a second noise to the west. It was an S6 noise, but it was still annoying because that's Australia, VK land, which I like to work in contests. I couldn't locate that one either. So by December 2015, I was kind of frustrated, to say the least. I figured I needed a new approach. So during Christmas break in 2015, I bought a GPS and started writing some beta code with the intent to collect S-meter data to see if it could be useful for finding this stuff. So the solution I came up with, it works well for me. Took some time to get there, but it was a color-coded map. It would show the signal strength and location, S-meter reading of the noise on the HF band of choice. I usually use 10 meters for most of my PLN stuff. I can usually identify down to the problem pole or plus or minus 1 pole, so I can get pretty close with the mapper. The laptop records the level and also announces levels every 10 seconds and also announces levels anything above S9. So as I drive along, I can kind of get a feel for, this is a noisy area, something's going on here. And at the same time, I'm recording the data. I can, once the map is generated, I can send it to the power company. It's usually pretty powerful evidence that something is not right. And my power line guy's gotten pretty good at looking at it and say, yeah, you're right. He does not argue with the map. He can see that something's not quite right. So once I fix it, I can redrive a route and also show it was fixed and things are good. And everybody likes to hear that, right? You did a good job. You cleaned up the problem. Boy, this area is really looking good. So I always give the engineer and the power company line crews credit for a good job. Well done. So we're going to look at some examples. And what we need for the examples is a scale. So S1 through S9 is pretty simple, but I needed to extend that over S9 in a simple way. So I defined S9 as S9 plus 0 dB, S10 as S9 plus 6 dB, and so on up the scale. So we'll see some numbers like S13, which don't exist in our world, but it makes it easier to register the magnitude. The scale I use is I use cold colors like green to indicate, okay, good. Yellow is, there's a little bit of noise going on here. And then orange, red, and then I ran out of colors, so I ended up using white and black and even a black star in one case. And these numbers you see after the levels are how many counts in the data set I was using. So there was one S13, which is a pretty hot level. There were 12 S12.3s and so on down. Whoops. And just to kind of set the scale here, anything above an S9 deserves attention, and anything above an S11 is a red flag, something you want to investigate. So here's the first example. This map was produced in January of 2016, just after I started using the RFI mapper. So my QTH is in the upper left-hand corner, 1.7 miles away from where the noise ended up being. And my power line guy, engineer, and I had spent a lot of time up in the left-hand corner of this map. You can see some orange and yellow up there. We were looking at power line noise, and we fixed some issues up there. We had the line crew come out, and we just never could make progress. I mean, we fixed some stuff, and it sounded like the kind of noise I was experiencing, but it never improved the situation. So it was clear after a while that there must be something else going on, and I just wasn't finding it. There was some dominant source that, yeah, you know, if I can clear the dominant source, then I'll be able to hear the number 2, number 3 sources, but I was having a problem that was dominating the noise floor. So once I wrote the RFI mapper beta software, I made a run out to the southeast with my wife. She was manning the laptop, kind of monitoring it, because it wasn't a real stable software at the time. It was you had to kind of keep a close eye on it. So we ran a route, and we went quite a ways out, so maybe about 2 miles away. Then I made a turn down a road that went down a ridge line. And when I started this, I said, I've been working on this problem for 3 months now. I'm just tired of working on it. I need to make some progress. I said, I'm going to drive till I can't drive any farther. I'm going to drive till I hit Lake Lanier. And at that point, it's, you know, another 3 miles across or 4 miles across Lake Lanier. The noise can't be that far away. So I just said, I'm going to drive everything. And no matter what I think or where I think it is, just kind of, I call it going to dumb mode. Don't think about the problem, just collect data and let the data lead you to it. So we drove down this road, and I forget the name of it, Sourwood or something like that. And you can see I got near the end, and there were some stars here. As soon as I drove into that area, my wife says, "This is the problem, isn't it?" And I says, "Yes, this is the problem I've been trying to find for 3 months and have been unsuccessful." So there was an issue down at the end of this road that was causing, actually there were more than one issue, but there was one really big issue. Kind of interesting too, when I drove a route just the lower right-hand side of this map, you can see some other blue stars there that were pretty strong, but oddly, I could not hear those noise sources. They're behind the ridge line, or the bigger ridge line, and so they don't really bother me. It was the ones that were on the ridge line where I had line of sight from my tower to these noise sources. And we're going to look at the source of the noise here in a second, but that's just a good example of, hey, RFI does not go through dirt very well. So if you have ridge lines that mask you from poles that are noisy, those poles that are way out are not going to bother you. It's the ones that you're line of sight to. So what was the cause for this first example? It was this bolt. In this case, the bolt was eroded 50% through, and the lineman, when he got up there, said he could smell something burning. And this pole, this arcing was going on, and it was creating enough heat to burn the creosote or whatever the preservative was on the pole, and he could smell that when he got up there near the top of the pole. It was a very calm day, so it wasn't like it was windy or anything, but a line crew was very sharp. They noticed that, hey, there's a problem here. This arcing's taken place. This bolt would eventually have worn through, and the cross arm would have loosened on the pole. Probably would not have fallen off, but it would have suddenly hung in the air or sagged or something. So they fixed this problem, and my noise issue from the southeast went from an S9 plus 10 down to an S3. So it worked pretty well. This is really an unusual one. Most of the time it's pole top insulators, bell insulators, or lightning arresters, but every so often you get a really odd one like this bolt that was arcing to another piece of metal. Here's a second example of a person that is a few miles away from me. I was talking to my power line guy, and he said I had an issue and they've been having some problems finding the source of the issue. So I drove this route, collected some data, and you can see 3 hotspots on the RFI mapper. And we're going to look at this one up here with the blue stars. So when I drove in, you can see I passed a couple of poles. I had a blue star, and approaching that pole, things went up in signal strength, and then moving away from it, things went down. And then same thing, I was recording as I left. You can see the other lane of traffic I was on. And as I approached this area, the blue star, then it went red, and then orange started tapering down again. And between those two blue stars was a pole, and that pole had a bad pole top insulator on it. So that was a pretty simple one. The mapper led me right to it. Third example, kind of interesting one. I had some noise to the southwest from me. It was during wet weather, which is kind of odd. Usually things get quieter. It goes away after several days of dry. And I ran this route, and it said, hey, there's something wrong right in front of this middle school. So I went over there, did a little exploring, and you can see the huge area that was polluted with RF interference. I mean, these red dots are really very strong, and the white ones are really strong, even stronger than the red, and the blacks are really hot levels. So you can kind of see that, gee, this is a quarter mile away. We're still getting significant RFI levels, and that's with a little 10-meter whip on a truck. It's not even a really great antenna. So I went over, did some exploring. I was out in front of the school and identified a pole. It was the one that fed three-phase to the middle school, and one of the lightning arresters was just going wild. It was generating all kinds of RFI, and identified it with the dish. Kind of interesting side note, I was out there, this was during the weekday, with a Yagi doing A/B tests between the poles, and I did it multiple times, and I went several poles away, worked my way back to the suspect pole just to make sure that I wasn't being led down a bunny trail and get into the wrong pole. The the police officer inside the school came out and said, what are you doing? And I looked at him and go, oh, I'm in trouble. But I said, well, I'm trying to trace down the source of radio interference. I'm a ham radio operator. And he said, well, some of the parents were driving in, and they were a little suspicious of you out with this broomstick and wire antenna. And I said, well, I use that to trace the radio frequency interference. He goes, so you mean like we use for tracking down hospital patients that have bands on their ankles? And I said, yeah, that's exactly the same technology. He says, yeah, I'm familiar with that. And then he thought for a second. He says, could this be the reason why my handy-talkie doesn't work when I'm out directing traffic? He directs traffic at the entrance to the middle school every day. I said, yes, sir. That is exactly the reason your handy-talkie doesn't work when you're out here. It's because this pole is spewing out so much interference because of the bad arrestor. I says, the power company will be out probably next week to replace it, and you should have much better performance. So sometimes you think, a problem only affects you, but it may affect other people. It may affect, in this case, public safety. He works in the 155 megahertz range. It could affect AM radio, FM radio, over-the-air TV, and even cellular. If it gets strong enough, it will extend all the way into the cellular bands at 600 and 700 megahertz. So you just never know. It just depends on the source and how quickly it tapers off. Last example, I had a problem. It was a really quiet area until mid-June. And we had a lightning storm, and then I had all kinds of problems. This is maybe a mile and a half away, but I can hear it quite effectively or easily on my Yagi antenna. It was originating at the corner of two large intersecting roads, where there was a pole with a lot of hardware on it. There was a three-phase running down this pole. It was a main feed, and it also had something called a recloser on it that would allow a circuit to, if it was an overload condition, it would open up, and then it would reclose when the overload went away, or would try and test to see if the overload is still there. I think it makes 3 attempts, and then it just locks out. But I had all kinds of problems with this this location. We were there like 3 different times, and it turned out it was a couple things. It was a couple of pull top insulators, and also a bad recloser. And they changed the recloser out, and it fixed the problem. So sometimes it takes persistence to fix some of these problems. So how does this third tool work, the RFI mapper? It's really pretty straightforward. It's kind of similar to what cell phone companies have done for about 30 years, except it's a whole lot simpler than that. Is I drive a route, I have a GPS on the top of the vehicle, little puck basically. It sends GPS data to the laptop. It does that every 1 second. So every 1 second, the GPS dumps the lat long to the laptop. That triggers the laptop to ask the radio for the S meter reading. And then the radio response, I usually use 10 meters because it's a good compromise between range and also sensitivity. When the radio responds with the S meter, the laptop stores the S meter data and also the lat and long to the hard drive, along with some other information like elevation, which comes handy sometimes. Also stores a number of satellites it sees, so I know the kind of the accuracy. If I can see 10 satellites, that's a pretty accurate dot on the map. It does 1 sample every second, so 60 samples a minute. If I drive a route that's 30 minutes long, that's 1,800 data points in a very simple flat file. And in 30 minutes, if I drive 20 miles an hour, I can cover 10 road miles of data. And that's a whole lot better than when I used to walk a road with the Yagi, where you can maybe do 2 miles an hour or something like that and cover maybe a quarter mile or something relatively small. The mapping is done with the Google My Maps, and that's not the same as Google Maps. It's kind of an offshoot of that. Pretty easy to learn once you've done it. It takes me about 10 minutes to map out something. You can have 10 layers of maps, each layer having 2,000 data points, so you can do some comparison. The hardest part is setting up a mobile HF in your vehicle, because you have to have all the things you need for a mobile HF. And then the other thing is you have to install Microsoft Visual Studio, which is a development package, but that's pretty straightforward. And if you're familiar with computer stuff, it goes pretty fast. Block diagram wise, how does Mapper look? Really simple. Laptop computer. Mine's more than 10 years old, so it's a really old laptop, but it works good. HF transceiver. I have a TS690, which is more than 20 years old, but it works really well. A friend of mine uses, or a couple of friends use K3s. They work also. And then a GPS. So really just 3 pieces to this puzzle. Now my HF transceiver is so old, it doesn't understand USB. It doesn't even understand RS-232. So I needed 2 extra things. I needed to convert the TTL output from the old Kenwood radio to RS-232. Then I needed to convert the RS-232 to USB to bring it into the laptop. So those were a couple extra pieces I needed for this old of a radio. So here's a picture of what things look like when I started out in 2016. It's in January when I first started using Mapper. And you can see there's 1, 2, 3, 4, 5, 6 major areas of concern that I kind of pinpointed, like I need to really work on these. And by August of 2018, here's what the map looked like. And you can see this school that I mentioned earlier, which I cleared. That's fixed now, so that's all green, and also the dots below that are fixed. That was another lightning arrestor. So things improved a lot, and I could really see it in my noise floor. Does the RFI mapper work? Yep, works really well. I've used it thousands of times. Fixed well over 100 of the big problems. You don't need to worry about small problems that are a mile away. You only need to worry about the big problems that are a mile away, or the small problems that are close. It's really handy to use to illustrate to the power company, here's what I see, here's where I think the problem is. Data doesn't lie. When you can take 2,000 data points, put them on a map and say, this is where RF interference is being generated, it's pretty convincing. So after 10 years of not too much progress, the mapper helped me reduce my S9 noise level to S2 or less. My northeast direction is now pretty good. It's S2 or better, which is nice. And in SSB mode, it's about S1 some days. So it's good. So now I work mostly in intermittence. Storms pop up, they blow out lightning arresters or something else. I have to go out and find them. So one question I get asked quite often is, how far do you need to go out and look? So based on my work and trying to clear things, I put together this simple little table based on what antenna you're using. So if you're just using wire antennas at 30 feet, you probably only need to consider things out to maybe a quarter mile from your QTH. If you have a tower, 50-foot tower and a 3-element beam, you're probably going to need to look out, in my opinion, half mile or maybe even a little more if you're on a hill where you can see line of sight farther. And if you have a 100-foot tower with a multi-element Yagi, you may have to look out a mile or farther. So what I have here is on 10 meters, I have 5 elements at 90 feet. So it's kind of an intermediate antenna. My noise level runs now between S1 and S2, depending on direction. If I'm not blocked by terrain like hills or gullies or whatever, I can routinely hear the big emitter noise sources out to at least a mile. Matter of fact, I just worked on one that was about a mile away to the west and identified a bad lightning arrestor. My longest confirmed distance was the first one I talked about. That was at 1.7 miles. It was down a creek valley. It was S9 plus and S13 on the RFI mapper. The longest suspect one I've worked on was a pole 3 miles away, located on a 200-foot hill. And once they cleared that a lightning arrestor, the noise went away. That was kind of interesting one too. I was talking to my power line guy, 4 of them working on it, when I turned it over to him, and he says, I thought you told me, Jeff, that you typically couldn't hear out farther than about 2 miles. This is 3 miles away. Are you really sure that that's the problem? And I says, yeah, I'm pretty sure, because I'd run every road with the mapper out to that distance and there was nothing. But I went out to that distance and it was the start of an incline up a kind of like a ridge line or a mountain ridge line, maybe 1,000 feet or so high. And I went by and it was really strong. I said, this is very unusual. This is not the norm. I don't expect many of these, but I'm pretty confident. And sure enough, that was the problem. They fixed it the same day the noise went away. So although I wasn't there to see it, I'm pretty sure that that was the issue. So a little, any questions? Well, Tom lied about you guys. He said you're going to have lots of questions. We'd have 3 or 4 guys asking questions at the same time, and you're all so quiet.
Jeff, can you hear me? This is Randy.
Yes.
Okay. I just would like to say it's very nostalgic, looking at your maps, because I lived in Gwinnett County in Decula, and I was active there until about 93. And then I moved, so now I'm up here. So it was very nostalgic looking at your map around Lake Lanier, and I've driven most of those roads myself.
Yeah, I bet you did. That's about the time I moved to Georgia. I think I moved here in '97 from Virginia. So you left and I moved, but
there you go.
A small world.
Yes, but yeah, it's very helpful. It sounds like you've accomplished quite a bit of, you developed quite a skill there tracking these things down.
Well, it was not necessarily an easy path, but I am a very persistent person. I don't like to lose. I guess that's the best way of saying it. And when I run up against a problem, I just tend to crunch away on it until I can figure out a solution. So believe me, there's been a huge number of rabbit holes I've stepped in during this path of finding noise. Hopefully some of the things I mentioned will help benefit some of you when you do run across noise problems and you have to troubleshoot them, because it's always nice to have it in the back of your mind. Oh, wait a minute, I heard about this one before.
Right.
So Randy, I have a question.
Sure.
You're out in the country. I did this for a living for a little over 30 years. My area of responsibility, I had cities. We had thousands and thousands and thousands over the years of RFI complaints. And I would challenge you to take your little box and come in the city of Buffalo or Niagara Falls. You would need but one color, red. You will hear noise on every single pole. I don't care where you go. And it would be literally impossible to, in the cities to trace it down. You're in a rural distribution area. But yeah, it's the city of Buffalo and Niagara Falls. They're horrendous. They're just.
Well, I've been all over the place. I've been down in Atlanta, and you're right. There are a lot of old poles in some of the cities, and they can be very problematic. But the good news is, and I did this for a good friend of mine who was having all kinds of problems down in Atlanta. I run a route, and you can shift the scale of the mapper program. In other words, you don't have to look at the S7, S8 problems. You can just change the colors, so to speak, and just plot the S14, S13, S12 problems. So you get a relative indication of the magnitude of the emitter and then how close it is to the victim receiver. And using those two things, you can kind of figure out that, okay, there's a lot of noise sources here, but here are the ones that really are killing us. They're the dominant sources.
Oh, absolutely. Yeah, our best tool was a little transistor radio. Just like you said, we had thousands and thousands of dollars worth of Stoddards and all this equipment, and a little transistor radio, a sledgehammer to wrap the pole to see if it changed. And that was about it. I just wanted to say, you said an engineer comes out. In my area of responsibility in New York, when a customer called in, just for your information, when a customer called in and it was a radio TV interference, they would send them a questionnaire, would be automatically generated. And, it would be things like, does your interference come on when it gets dark or when it gets light in the morning and things like that. And, you could narrow down a lot of them right then and there, because about 70%, I think it was 72% over a 10-year period were customer-owned problems. Oh. And, people, you go to the door. I told these guys this over the years in the Zoom room here. You'd go to a door and, the doorbell doesn't work. You'd walk in, meet the customer and say, how long has your doorbell not worked? Oh, about a month. How long has your interference been on? About a month. Okay, there you go. Oh, you have a fish aquarium over here, I see. Yeah. We just, and it's wintertime, the high-low limit switches, and the list goes on. You could troubleshoot from the living room door.
I've been waiting for my first doorbell issue, and so far I haven't found any. And I haven't found any aquariums yet either.
Jeff?
Yes.
One of the things I previously lived in Long Island, New York, and one of the things apropos to what Dick was saying, we were loaded with ceramic insulators, glass ceramic insulators, and with the salt air, they would of course get the hairline cracks, and it was horrible. My former next door neighbor and I used to go out with the sledgehammer and the AM radio and whack the poles, of course, until the police came. Whack the poles.
If I could just piggyback on that, Jeff, when you were talking about the insulators, very seldom did we ever find bad insulators. I mean, there are bad, but most of the time it was the tie on the insulator. Depends upon the tie wrap on the insulator. Many times.
Yeah, we would get the old brown ceramic insulators. If they were gray, we knew they were good. But the brown ones used to get the hairline cracks, and then the salt air, we were near salt water, would really create havoc. So, Dick, your system with the sledgehammer worked good, as I said, until the police came.
Well, we were a power company. We were the ones that found the interference.
We were two wacky guys who would try to locate the stuff. Let
me tell you a short story on the pole top insulators. My power line guy and I were out with a line crew one day, and we found the source of the noise. It was a pole, it was a 3-phase pole, had 3 pole top insulators on it. And we used the commercial dish to identify, and also my dish to identify the pole tops. And so we talked to the line crew chief and said, we'd like you to do the rewraps. There's a metal, it's almost like a heavy gauge wire that they use to attach the main transmission line to the pole top insulator. So it's a wrap wire is what it is. And my engineer friend and I had come to the conclusion that that's the source of most of these problems. It's not really the insulator. The insulators are fine. It's just the wrap wire. So we talked to the line crew chief and said, can you rewrap those 3 lines, those 3-phase lines? And he looked at us, and I know he wasn't real happy with our suggestion. He goes, well, normally if we have an RFI problem, we just replace the pole tops. And my buddy Vic and I said, no, we don't want to replace them. We don't think they're bad. Just do the wraps. And he just shook his head, and I thought, uh-oh, that's not a good sign. So he went up there with his crew. It was not an easy pole to work on. It was hard to get to all 3 of the insulators. He rewrapped each one of them very carefully, did a great job. All 3 of them still produced RFI. And my engineer friend and I are looking at each other, and we're going like, well, there goes our theory about wraps causing the problem. And then he said, well, can I, the line crew chief says, would you like me to replace the pole tops now? And we shook our head, yeah. And we're going, can that really be the cause of it? So he put new pole tops on it, and all 3 of them were just totally quiet. So it took him twice as long to do the job because he had 2 engineers interfering with the process. Basically, he would have just changed them out. So now, from the standpoint of cost, we just have them replace the pole top, and the wrap gets changed too. So interesting story.
Hey, Jeff, great presentation. I was wondering, you talked about power line noise. What about noise that comes from underground utilities and the transformers that we find in our neighborhood that are, feeding our homes from the underground lines? Are there, I know that there's been arcing underground. I've seen it happen, typically after a hard rain. But did you find many examples of power line noise from underground utilities?
Well, I'm still looking for my first case of underground line noise. So we do have quite a few subdivisions around here that are fed underground. I have yet to have any issue, partly I think because it's underground, so it's kind of hard to get RF through dirt. And then eventually they'll burn themselves out also. But I have not found any. The transformers seem to be pretty reliable. I guess they could arc, and if you're close enough to it, it's a metal cage, so to speak, so there's some RF shielding there. It's hard for the RF to get out. But I have not run across one yet, which is kind of amazing. Let me continue on here because I'm going to talk about some other noise sources, things I've found. So we've kind of focused on power line noise so far, but that's maybe, at least for me, it's about 80% of the noise sources, but there's another 20% that you need to consider also. So I took my Yagi and walked around the house and kind of identified things that were suspect. In other words, they were producing lots of noise up in VHF at 137. And then I kind of also correlated that to noise I had on the HF radio down on in this case, the lower band. So the first thing I found that, hey, I got a problem here, was the router group. I have a cable modem, a router, and a VoIP unit. And when I measured it to kind of get an idea, is this a big problem or not, it was a plus 21 on my attenuator. And my noise level on 80 meters was a S7, which is kind of high. And I knew it was high, and I could hear something that didn't sound all that good. So that's one thing identified that required some attention. The second thing was I had a Mr. Coffee LCD coffee pot, and that was producing about a plus 18. And I decided, hey, if I unplug this, it goes away. And that thing ended up not being plugged in when it was not being used. So that was another concern. And the third thing, I had a Dynex TV, which was producing a plus 12. And keep in mind, all these things are only 50 feet or so away, or maybe 75 feet away from my antenna. So the distance is short. And even though they're weak, they're very close. Turns out the router group was the dominant source in this case. So when you consider your antenna placement, keep in mind distance is your friend. You want to move antennas away from houses or anything that can generate RFI if you can. Sometimes it's not possible. And we'll talk about free space path loss in another slide, but just kind of keep these things in mind, and keep in mind too that you may be shooting yourself in the foot if you haven't evaluated things that might be inside your house. Lessons learned: wall wart switching power supplies, the things you plug into the walls that power just about everything nowadays. It can produce lots of noise, especially on the low bands, 80 and 160. You can use some snap-on toroids with multiple turns on the DC side and the AC side, but it's usually the DC side to quiet those guys down. If you have a separate cable modem and router, one thing I discovered is the router is powered by a switching mode power supply, just a simple 2-wire thing. There is no tie back to ground. It kind of just floats. It's got a metal cage in it, yes, but the electronics in it have no connection to ground. And I found by using a short shielded cable, in my case a Cat 6A, between the modem, which has a very good ground because there's a grounding block as it enters my house, and the router, that helped a lot. Knocked about an S unit off my noise floor. One thing I learned while doing that: do not order Ethernet cables from common internet sites. I did that initially, and things weren't working out as well as I thought they would. And I ended up measuring 2 to actually 20 ohms on a group of 5 cables, shell to shell. And on the shielded cables around the RJ45 at each end, there's a metal shell. So there was resistance there, and that's because the drain wire that grounds that cable, grounds the shielding in the cable, is just laid across the metal shell. It was not soldered. So I ended up doing some research, found some Amphenol cables on Mouser.com, and their spec sheet said drain wire soldered to the shell at both ends. And I bought 5 of those, and they worked great. They had less than 1 ohm for each one of the cables, and my noise level fell from S7 to S5, so 12 dB of improvement by doing 2 things. One is the wall wart with the toroids, and the other is running a shielded cable. It's just a short cable, about 3 feet, between the cable modem and the router. Here's a picture of what that looks like. You can see I'm using a commercial isobar on the AC line, which works pretty good to keep the noise from being dumped out on the AC side. And on the DC side, for the little SMPSs, you can see a couple of toroids on the cable modem and also on the router feed that goes to the those devices. And that fixed the problem, worked really well. What you will want to do is make multiple turns through those devices because it's a squared function. So if you go through it once, you get the base impedance. If you go through it twice, it's 2 squared, which is 4 times the base impedance. If you go by through it 3 times, it's 3 to the second power, so it's 9 times the base impedance. And there's a really good website done by Jim Brown, K9YC. You'll get to the site and you'll go, man, this is a lot of information, more than I need. So somewhere in there you'll find his table where he talks about small, medium, large toroids, and I have a ample supply of each one of those things. They're $3 to $5 typically, and I use them quite frequently on all kinds of things. So results. So after my work trying to control my noise, where did I end up? Here's a graph from back in 2016, and I ran 2 different routes, or I actually collected data from my my Yagi antenna. I rotated the antenna through the different directions for this graph. And you can see, depending on the day, the blue line was on one day, the red line was on a different day where it was really bad noise to the east. It wasn't all that good, even on a good day. And after improvements, here's what my noise level looks like. So my objective was S2 or less on 10 meters. You can see on some of the days and directions, I was actually better than S1, which is pretty dang good towards Europe. I can really hear the weak multipliers and work just about anybody I want to. So definite improvement. Not perfect, but it's hard to achieve perfect in the noise world. So kind of a summary of how I approach noise problems. You want to clear the local area noise, and to borrow a IT term, LAN, local area noise, I use the 137 megahertz Yagi and attenuator and HT to locate the noise inside your QTH and also outside the QTH. When the pole, I use an ultrasonic dish to ID the part on the pole, or you can use the power companies. I typically have one. And if the noise persists beyond that, you can use a car radio or an RFI mapper to look out on a big scale if you have a tower and high gain Yagi. And there was a thing mentioned earlier. Here's a little picture of what your noise level should look like, and kind of compared to what an ITU spec said it should look like and what I measured. So on 80 meters, you should see S6 or less. On 20 meters, S4, and on 10 meters, you should see S2, just to kind of give you some watermarks there to consider. Let's see. Oh yeah, I talked about free space path loss. Something I always try and keep in mind, and this is why RFI mapper works, is you cut the distance to a noise source in half, the signal goes up by 6 dB. So as you approach a power pole or any kind of noise source, every time you have that distance, you're going up by 6 dB. And the same is true. If you can double the distance to a noise source, it's going to go down by 6 dB. And you want to use that to your advantage to keep your antenna away from noise sources if you can. I know it's not possible in all cases. I've lived in places where you couldn't do that. But if you can, you want to put your antenna out in the woods because you're not so susceptible to generating interference from your own house, as well as what may be close neighbor-wise. So kind of keep that in mind. This was one interesting thing I'll make mention of. It may affect some of you. I had a noise source to the northeast. I went out there and spent a lot of time looking at these power poles, and you see them on the left-hand side here. And I walked a lot of distance that day, looking at these power poles with the Yagi and the dish, and I could never really come to a determination as to which pole it was. And I just happened to sweep the dish down lower, and it peaked. It got really noisy. And I go, well, what's going on here? Something screwy's going on. Well, it turns out during very dry spells, the ground dries out. These posts you see that are pounded in the ground that support the fence no longer are good grounds. Well, this fence is running underneath this power line for a very long distance, and there's voltage being induced by the electric field of the power lines. So these wires get, although they're somewhat low, they get a certain level of energy in them, kind of like a transformer, and that is looking for a way to ground. Well, it finds the way to ground with these joints. If it's just traveling along horizontally, no problem, but every so often it'll build up enough and it has to find a path to ground, and it goes through these metal joints, and these metal joints create RFI, just like a diode would. It's a nonlinear junction. Well, I happened to just scan by a couple of those, and I go, what's going on here? And I found about 12 joints on this fence that exhibited that property. And as soon as it starts raining, where all these posts seem to provide good grounds, the noise is gone. And every fall I go through this in October, usually when we get a dry spell, I know, especially if I drive by with RFI mapper, it's going to light up in this area. And it's not from the power poles. So that's a really odd one. You just never know what you're going to run across when you're hunting RFI, and you have to kind of be aware of your surrounding.
Jeff?
Yep.
I happen to have an electric fence, and it generates great noise as well. I don't know if you ran across them.
I don't have any here locally. That may not be a joint problem. That may be the actual device or the electronics that generates the voltage. And typically that's where you have to squelch that noise as it comes out of the fence box, the feed from the box that's generating the high voltage to give the cattle or whatever a little tickle. So I think you might want to, if you want to solve it, you might want to do a little searching on the internet. And I think the end result was to put a custom made choke on the output of that feed that drives the fence.
Yeah, I can look at that. Actually, the way this one works, it's solar powered and has a, I guess, a switcher, and it builds up until it discharges in other words, a very cheap, non-regulated, and the way it regulates is by discharging.
I've never heard of a solar one before, but I guess it's possible.
But it works. It works for its intended purpose. It's just something I have to live with in the summertime. But they're all kind of different kind of fences, and they can have all kind of different problems.
One thing I'll make mention of, we talked about hunting noise, and it's so much easier to hunt at VHF, but every so often you get a problem that is a low band problem or an HF problem only. So I have a couple of loop antennas I use for that. It's much trickier to locate because this loop is bidirectional. So you have to take a reading and you say, yeah, the noise is along this line, but it could be in front of you or behind you. So then you have to move maybe 100 feet or 200 feet down the road, take another reading, and you come up with another line, and where the two lines intersect is where the noise is. And I've done that successfully quite a few times, but it's a slower process when you have to hunt it down at 4 megahertz, or the other problem I had was up at 15 meters, so around 20 megahertz. It can be done, but it's just a slower process. So I think that kind of sums up what I wanted to talk about tonight. So hopefully some of these tips will aid you in your quest to lower your noise floor and improve your ability to hear DX stations.
Can I ask you one more question?
Sure.
We experienced some noise here, and I'm looking at it right now. A couple of other hams in the area. On 80 meters, something around 3.8 meg. I'm seeing a noise, goodness, right now, it's between S5 to 7, but it looks like lightning or static crashes. And I don't see any storms quite that close to us right now. So I'm just curious if actually.
Yeah. I'd say a good chance that is lightning. There is a website called Blitz or Tongue. I think it's BLITZORTUNG. I think it's run out of Germany, which is that's their name for lightning. Okay. And it is a great aid in seeing if there's any storms in the area. You can bring that up, and then let me see if I can do that and show it on the.
I've also got an app on my phone that shows me the nearest lightning strikes, and I think it's showing things actually closer to your part of the country at the moment.
Yeah, let me stop share here a second. Okay, so here's this Blitz or Tongue site. I'm not sure if you can see that or not, but you can see some white dots on there, and it will flash every time a lightning strike takes place.
Yeah.
But I use that quite a bit to look at, hey, are things close to me, or is it totally quiet? And you never know how far that's propagating, right? On one band, it may propagate farther than on another band because it's reflection, just like an RF signal. But I can see now that there's some issues down in New Orleans, kind of southern Alabama, and also in Florida are the things that could affect it. Usually on if it's a lightning issue, if it's on a pan adapter, you'll see a horizontal line that's very strong, and it goes away after basically milliseconds.
Yeah, that's what I am seeing. Looks like lightning to me.
Yep, probably is.
The closest lightning, according to my app, is 828 kilometers right now away.
Yeah, it's a long ways away.
Yeah, that's what surprised me. I thought, wait, it's closer than that. for the amount of static that I see. And it does look like lightning, the horizontal lines.
Yeah, I'd
that
wait one
cause-
day. Wait one day, see if it goes away. There's no sense in chasing problems
Yeah,
that
sure.
are transitory like that.
Yeah. Thank you.
So if you get a chance, pick your band of choice, flip over to AM, take a close listen and see what you hear. If you hear a nice gentle hiss, there's no issue with that band. You can try another band you operate a lot. That's the criteria I use for most of the people I talk to is, if you can't hear it, it's not affecting you. But if you check the two bands you operate on most and you hear something that's not a nice gentle hiss, then it may be time to take a look and see if you can get rid of it. Sometimes it's a simple fix like, oh, gee, I have a router sitting near my antenna and I'm generating my own noise. And that's always the worst case. I'd say it's like shooting yourself in the foot, right? You're causing your own problem. And they're easy to fix usually in cases like that. And sometimes it's, maybe your neighbor or sometimes it's a power line problem and you have to work with the power company. So some things are easy to fix, some are not so easy to fix. But as I always tell I have a friend that's ex-fighter pilot, never worry about the solution until you know the problem. First, diagnose the problem, make sure you're 100% sure what the problem is. Then you worry about the solution. Is there a solution for it? In most cases, the answer is yes. Any other questions?
I got a quick one here. Let's say it turns out to be your neighbor, what can you do about that?
Well, that's a good question. I've been fortunate. All my neighbors and I get along really well. I help them whenever I can. I try and stay friendly. I always say hi to them, even if I don't necessarily care for the neighbor. I still try and be friendly to them. It's not always easy. So stay on good terms with your neighbors because you never know when you're going to need them for whatever reason. I had one case that was especially interesting. It was a ham that lives maybe 40 miles away from me, and he had a terrible interference on 80 meters right around the top end of the band near 3.99 megahertz. There was a net he liked to join every day, and he had a carrier that would float across there. It was a fuzzy carrier, made all kinds of noise. And so I went up and we did some basic stuff. We found a couple things in this house. A coffee pot was making noise. We found a LED lamp, one of the first LED light bulbs. He'd bought one, put it in, and it was making noise. And I said, you need to replace that with a newer one, newer style. And then we went out in the truck looking for the noise source. And I had my mapper on. I said, let's just do a drive without actually mapping. And boy, he was in a valley that was really quiet. But when we got near his house, things got bad. He was on a gravel road. So we drove up the gravel road and it kind of peaked in an area by a house. And he goes, that's my neighbor and we don't get along very good at all. I says, okay. And I was worried already because the worst place you can have a problem is sometimes where you have it. So we drove up the road, went half mile past and the noise tapered off. We drove back down the road. Yep, it's there. And we did it one more time. We went up the road, and about that time, the neighbor jumped on his four-wheeler, came over and said, what are you doing? I says, well, I'm helping my friend here. And he recognized his neighbor who he didn't get along with. I'm helping him work on a problem. It's an interference problem. We're trying to track it down, and it seems to be coming on this direction, kind of from the area of your house. And he looked at me with kind of a strange look and he says, could this be related to the fact my internet goes out sometimes? And I said, well, it could be. I said, the two could be related somehow. We don't know yet. We're not even sure what this noise source is. So he was actually very nice. And of course, I was kind of careful when I talked to him and explained we don't really know where the problem is and all that. So he says, well, come on in and take a look around. Maybe you can find it. And it turns out he had an older PC that when it was plugged in, the power supply was generating noise. It was a switching mode power supply, one of the older ones. And the power supply was using the wiring in his house as the antenna. And it was radiating probably about 300 or 400 feet down to my friend's house. on 80 meters. He unplugged that, the noise went away. And then his problem was what appeared to be, he had a phone system, a cordless phone system. And every so often when he went to use it, it wouldn't work. He thought it was a data problem. He talked to the DSL provider. They said, you know, we don't think that's the problem. And he says, well, it seems like all of a sudden my calls go, you know, to really noisy. You can't talk over it. I think it's a data problem. I ended up writing him a kind of a description of what I thought the problem was. I think it was interference from another device on his cordless phone, because it acted a lot like, so I never got the final resolution of that, but I pointed him in the right direction, said, you need to take a really close look at any other devices in your house, even microwaves, that might generate noise on the same frequency as that cordless phone. It was an older cordless phone. But anyway, he was very good to work with, even though my friend didn't get along with him. So the moral of the story is just try and be friendly, try and be helpful, don't be accusatory, and do the best you can. It also helps too, when you're talking to him, you have to think about, how do I explain this problem in simple terms, because you don't want to get too complicated with a non-technical person. You know, pictures are really helpful, or recordings. What I found with my neighbors is, if I approach them with my handy talkie on in the Yagi, they can hear, as I sweep by their house, the noise. And RFI typically sounds very nasty. If you sweep by an RFI source, whether it's power line or switching mode power supply or anything else, as you scan by it, it makes a ruckus. And you want to have the attenuators off in your little attenuator so it's nice and loud. And when they hear that, they get a little concerned, like, gee, could this be a potential problem? Could it be a safety issue? You know, you don't know. Any other questions? Micah, you've been awfully quiet tonight.
Well, thank you, Jeff. I just wanted to say that is the most comprehensive thing I've ever heard on RF interference. It really, there's probably plenty of things wrong around here, and now I know how to hunt them down. And I will look forward to emailing you and maybe getting the blueprint, or the how to build that Yagi and
Sure.
The attenuator.
Yeah, I have some pictures and a nice description of the Yagi, and like I said, it cost me $0. I had a piece of cable and a broomstick, and I am sometimes embarrassed to say it was intended to be a prototype, used like once or twice, and now it's been around for maybe 15 years. One other interesting thing my wife asked me one day, this is some time ago, she goes, is all you ever think about noise? I said, you know, maybe you're right. Maybe that's all I really think about. There's not a whole lot, but noise is one of them. And trying to drive the noise floor down lower is an interesting mental exercise, and persistence is a really important part of that.
But I just wanted to say thank you, and it was
Sure.
It's a real eye opener, and I look forward to making this a project.
Yeah, if you all have any questions as you hunt noise, let me know. I have plans for the Yagi attenuator thing that very simple to build. And if you ever really get into the deep of it, you can go farther and build a ultrasonic dish or the mobile system. But you have to really be into noise hunting to want to go that far. But simple tools are good, and the Yagi is definitely a really good one.
Hey Jeff, is the slide deck something that you can make available, or is that something that you would rather we email you to get a copy of? And thank you for the interesting and useful presentation.
Yeah, I haven't sent the full slide deck out, but if you have anything of interest you want to get from that deck, I can put a portion of that together. If there's some section of interest or whatever, that's not a problem. Just let me drop me an email. My email address is on my QRZ web page, or it's just W4DD@ARRL.net.